All right, in this little video, we are going to use reasoning to make the most logical conclusions. And this is the kind of thinking we need to do when we do proofs. So if you have the little pink packet that has all the proof reasons, take that out and look at that while we're working with that, because I want you to be able, you'll be able to use that for tests, so I want you to know how to use that. So now let's say that you are given the statement that M is the midpoint of PR. So what we're going to do is I'm going to kind of make two columns here. A statement that you could make if you were given that, and what the reason for making that statement would be. So if M is the midpoint of PR, what I would first do is draw a picture. So you have segment PR, and if M is the midpoint, look in your look under segments and look for the definition of midpoint. What does that mean? It says M is the midpoint if it divides a segment into two congruent segments. So by definition, we could say that segment PM is congruent to segment MR. So that would be the next logical statement that we could say. Here it's a midpoint, so what do you know? That segment PM is congruent to segment MR. Why did we figure that out? Because of the definition of midpoint. All right, let's look at the next one. It says angle 1 and angle 2 are vertical angles. So if you go to your pink sheet and you look up, go under angles and look for vertical angles. What is the definition of vertical angles? Well, we have the vertical angles congruence theorem that says, oh, that's right angles. Vertical angles congruent says vertical angles are congruent. So if angle 1 and angle 2 are vertical, what do you know? The next logical statement would be angle 1 is congruent to angle 2. And that is the vertical angles theorem. So vertical angles congruent theorem. Let's look at the next one. Angle 1 and angle 2 are a linear pair. So let's look at angles and find where it says linear pair. Let's see, the definition says two adjacent angles that make a straight line, but the linear pair postulate says that if angle 1 and 2 form a linear pair, then they are supplementary, and the measure of angle 1 plus the measure of angle 2 equals 180. So the linear pair postulate says that the measure of angle 1 plus the measure of angle 2 equals 180. And why do you know that? That's called the linear pair postulate. Or you could also say that angle 1 and angle 2 are supplementary, and if they're supplementary, then you could go on to say that they add up to 180. But because they're a linear pair, it tells you right there that they add up to 180. I would go with that. All right, the next one says angle 1 is a right angle. So again, what is a right angle? Go to the definition. It says definition of a right angle, it's an angle with a measure of 90. So if this says that you have a right angle, the next logical statement would be that the measure of angle 1 equals 90. Why did you know that? Because of the definition of a right angle. Now the next one, I always think these are a little bit strange, but it says y is between x and z. So first I would draw a picture. So here is x and here is z. And I should say point x and point z, and point y is between them somewhere. So what kind of statement could you make with that? So if you look at your segments, the very first thing that you have under segments is a segment addition postulate that says the two small segments add up to make the whole segment. So when you're given something like this, you could make the statement that the length of xy plus the length of yz would equal the whole thing, which is the length of xz. And that is the segment addition postulate. The next one is similar. It says A is in the interior of angle XYZ. So point A is in the interior of angle XYZ. So draw a picture. And if point A is in the interior, if you drew a line from here to here, what do you know? Well, we don't know where it's located. I mean, the A could have been up here or here, so I don't know that it's in the center. So I can't make that conclusion about the angles. But what I do know is that if you add up this one plus this one, it will equal the whole angle. So the two smaller angles add up to the size of the large angle. So what you could say is the measure of angle XYA plus the measure of angle AYZ equals the measure of the whole thing, angle XYZ. And why do I know that? Because of the angle addition postulate. All right, the next one says that if you're given the measure of angle 3 plus the measure of angle 4 equals 100, and the measure of angle 1 plus the measure of angle 2 equals 100, what would be the next logical statement you could make? Well, if this equals 100 and this equals 100, they both equal 100, then this and this equal each other. So you could say measure angle 3 plus the measure of angle 4 equals the measure of angle 1 plus the measure of angle 2. And why do we know that? If A equals B and B equals C, then A and C are equal. That's the transitive property. All right, the next one says, given that measure angle 2 plus measure angle 3 equals measure angle 1 plus measure angle 2. So what would be your next logical statement? Well, they both have an angle 2. So what you could do is you could subtract the measure of angle 2 from both sides, and what would you end up with? The statement measure angle 3 equals the measure of angle 1. And how did you get to that logical statement? By the subtraction property of equality. All right, the next one says the measure of angle 5 plus the measure of angle 6 equals 90. So let's look at our angles. We look at two angles that equal 90. What would we say that they are? They are complementary. So you could say angle 5 and angle 6 are complementary. And how do we know that? Because of the definition of complementary angles. All right, the next one says the measure of angle 9 equals 90. Well, if an angle equals 90, what do you know about it? It is a right angle. That's the definition of a right angle. So angle 9 is a right angle. Why do you know that? Definition of a right angle. All right, the next one says if you're given that angle 1 and angle 2 are supplementary, what could you say? Well, look up what it means to be supplementary. It says two angles that add up to 180. So your next logical statement would be angle 1, the measure of angle 1 plus the measure of angle 2 equals 180. How did we know that? Because of the definition of supplementary angles. The next one says segment ED bisects angle FEG. So let's draw a picture. So we have angle FEG and ED bisects it. So let's look at what a segment bisector is. The definition of a segment bisector at the bottom of the first page. It says a point line ray segment that divides a segment into two congruent segments. Okay, so what do we know then? That these two angles, that was segments. I should have looked at the right one. Angle bisector. array that divides an angle into two congruent angles. I know that the angles are congruent. So if it says that ED bisects an angle, my next logical statement would be to say that the measure of angle FED, so from F to E to D, that's this one, is equal to the measure of angle DEG. And that would be the definition of a segment bisector. Oh, did I say that again? I keep looking at the wrong line. We're not talking about segments, we're talking about angles. So the definition of an angle bisector. And technically it says that it divides them into congruent angles. So you know what? I'm actually even going to switch this. And I'm going to write that angle FED is congruent to angle DEG. That is what the definition of an angle bisector says. After that, I could make a statement that says if they are congruent, that the measures are equal to them, to this, based on the definition of congruent angles. Oh, and I have more here. This is longer than I thought. Let me just erase this quickly and we'll go through all of this together too, because these are so good. And that's it. Okay, so given angle 1 is congruent to angle 2, this goes back to where I just was. I was getting ahead of myself. If angle 1 and angle 2 are congruent, so let's look at angles and congruence. Where is that at? That is the second one. It says that two angles are equal if and only if they are congruent, which means if two angles are equal, then they're congruent, and if they are congruent, then they are equal. So if they are congruent, my next logical statement would be to say that the measure of angle 1 is equal to the measure of angle 2. That is the definition of congruent angles. The next one is dealing with segments, and it says they are congruent. And if you look at congruent segments, it says if they're congruent, then they're equal, and if they're equal, then they're congruent. So you could say the length of PR equals the length of AB. That is the definition of congruent segments. This one was angles. Next, it says angle 3 and angle 4 are complementary. So let's look at complementary angles. Two angles that add up to 90 is the definition. So you can put the measure of angle 3 plus the measure of angle 4 equals 90, and that is the definition of complementary angles. And let's look at the next one. It says given line ED is perpendicular to line AB. So this is line ED, and then this will be line AB. And you know what? We're going to give this a point X right here. Okay, and so if they are perpendicular, let's look at perpendicular lines. What's the definition of perpendicular? Two lines that intersect to form a right angle. So what we could say then is that angle AXD, angle AXE, angle EXB, okay, and then angle DXB. So AXD, that's this one. AXE, that's this one. Angle EXB, XB, that's this one. And angle DXB, that's this one, are right angles. Okay, and that would be the definition of perpendicular lines. That's the symbol for perpendicular. Okay, so that is the worksheet. Next logical statement. Thanks for watching.